You are the hostess with the host with the most.
Thank you very much. So this is 9:35. So we are going to officially begin our lab session. Before we go for the actual notebook, I want to briefly talk about the announcement that we have made public for all of you. The announcement is about your midterm exam and the fact that it is going to have two parts. The first part is an in-class section, which is scheduled for this Thursday, September 24th, during the lab session. On that day, we are going to start the class on the regular Zoom meeting that you always join. Dr. Cleveland is going to go over some important remarks, and then we will begin the in-class section. So try not to miss that day, or that you will miss half of your midterm exam. You will have 50 minutes to complete it. It is designed as multiple choice questions mostly, and then there are a few questions that will require you to work on codes. You're allowed to have, I'm not still looking at the chat box, I will be there in a minute. You're allowed to have access to CoCalc, Google, and your own notebook copy. So all online resources are available to you. The only thing that is restricted is different forms of communications with other people, including your classmates. So don't do that. That is the only restriction. You're required to join the regular Zoom meeting link, the same one that you are in right now. And we want you to activate your video while you're working on the exam. And by this, we don't mean that we want you to do a screen capture or record your screens. We mean that we want you to turn on your webcam so that we can see you on the other side. Then, on Thursday, around noon, so right at 12, we are going to make the take-home section available. You will have 24 hours to work on it. So it will become available on Thursday, September 24th at noon. And the deadline for that is Friday, September 25th at noon. It is designed based on the materials that we've covered in the class and in the labs. Similar rules apply to this one as well. You have access to CoCalc, Google, your notebook copies, and we don't want you to use or basically communicate with each other. And at the end of the day, we want you to submit your notebooks as notebook files with the format .ipynb, and we want you to also upload a PDF of that notebook, and we also want you to upload the CSV file that is required in the question. You do not really know about that until you get the questions. But at the end of the day, we want 3 files. Your notebooks as .ipynb files, a PDF of the same notebook, and the CSV file that you will have. So let me have a look at the chat box and see what is happening. Can I use my phone's camera? Yes, you can. Does the in-class section apply to fully online? Yes, of course. Hard drive is full. Oh, it's wrong one. Safari could download. I had a question on what you're looking for when describing the head function for lab 8. Basically, Max, we want you to run that and tell us what you can see. That will give you some information about the data set, the data frame. And we want you to go ahead and describe that kind of briefly. We don't want you to write pages about it, just maybe 1 paragraph, 2 or 3 lines. Okay, I see no more questions in the chat box. Do you have any questions about the midterm exam? If you have questions, you can unmute yourselves and ask. Otherwise, we will go and start working on Lab 9. Okay, so you should have access to the materials that you need for this lab through Blackboard under Lesson 9, under Laboratory 9, and that will take you to this directory. And we want you to download all of these. So basically it is one Python notebook, lab9-deploy, and then 4 CSV files, census underline 18, Galton underline subset, NC-ESD 2015, and so on, and then top underline movies. One Python notebook, 4 CSV files, download them from this link and upload them to your CoCalc account. And then you will have this in front of you. Is there any questions about that? Okay. So, very similar to the previous labs, we want you to fill this cell information with your own information, your own names, your own R numbers, your hex code, the title of the notebook, and the date. That should be pretty familiar for you at this point. Last week, we talked about the NumPy library, the Pandas library, and this week we are talking about the Matplotlib library. So at the beginning and the top of your notebooks, you have a cell like this, which is basically importing these 3 libraries for you. If you run this, that's a big if. If you run this for the rest of this session that you're working on this notebook, you do not have to import these libraries again. However, you will save this library today. Let's say this afternoon you want to go back to your CoCalc and do something. If you just jump to a cell in the middle of your notebook and you run a function from one of these libraries, that will give you an error. Because every time that you restart or refresh a session, you need to import these libraries again. Otherwise, Python will not know what you're talking about and what you're asking. So, we are importing NumPy as NP, Pandas as PD, and matplotlib.pyplot as PLT. So from this point on in my notebook, whenever I say MP, I mean NumPy. I say PD, I mean Pandas. When I say PLT, I mean matplotlib.pyplot. So run this. And then we are going to talk about line plots. As Dr. Cleveland has already explained, you are familiar with line plots, and we're going to work on this exercise together. So, in exercise 1, a table is given to you that contains experimental observation. You have 2 columns, elapsed time in seconds, and then speed in meters per second. That is in SI. Thank you very much, Dr. Cleveland. So we have a list of different values for elapsed time, and then we have the speed measured in those intervals. The question wants us to plot the speed versus time, the speed on y-axis, time on x-axis, using a line plot. From examination of the plot, estimate the speed at time t equals to 5 seconds, and that will be an eyeball estimate. So, I do not expect you to be able to do this right away, but I think you remember enough from what we did previously in our functions lab and what Dr. Cleveland has told you that I can go ahead and give you 1 minute and ask you to share your pieces of code with me for the first part. So create 2 lists for time and speed. Go ahead.
Dusky. Welcome back.
Do you have anything yet? That is simply creating two lists for your time values and your speed values. Brandon is the first one. So, let's see what he has. He's creating a list with all the values from the table under elapsed time column, and he's calling that time. And then another list called speed for all the values that he saw under the speed column. So I can actually go ahead and have these printed as well. And if I run the cell, I will have the two lists. So thank you, Brandon. And Andrew, I think you are following the same steps, and that looks good to me. So thank you very much for sharing. Then we are supposed to create a line chart of speed on y-axis and time on x-axis. So if you look at this cell, you do not have these three lines. And do not worry about that. That is something that I added after Dr. Cleveland suggested something in his lecture, and we will talk about that. So I want you to go ahead and create a line chart of speed on y-axis and time on x-axis. Try to remember what we did during the lab session for functions, and we created plots. So I'm waiting for your answers. Jacob. So let's see what you have. So you are saying that you want to go with the plot function from PLT, and you want to plot time and speed, and your title for the plot is speed versus time. It's a string. Your X label is going to be time, and your Y label is going to be speed. Okay, a few things that you may want to consider. When you are setting up titles, we want you to mention the units. So for example, if this is time, we want you to go ahead and say in seconds. Or if this is speed, we want you to go ahead and say meters per second. But overall, this looks nice. Before I run it, let me tell you what is happening here. You don't have to do this. This is just something that Dr. Cleveland suggested, and I thought it might be cool to add. So I'm importing an external library called IPython, and I'm using a function called display.audio, and that will give us a tada sound effect. So let's hope that the plot works. And here, did you hear that?
Yeah, cool.
You are getting this plot, which starts at 0.00. You have time in seconds on the x-axis. You have a speed in meters per second on the y-axis, and you have your title there. But what if I want to change the color? What if I want to make this look more aligned with my preferences? So let's say I want it to be plotted into red color. What can I do? So I'm looking at Jackson's suggestion in the chat box, and I'm going to go with that and see what will happen. So time, speed, let's go with red. He wants his marker to be like a triangle, and he's going with line width 1. So his plot is going to look like this. I'm actually going to hash these. So his plot looks like the way he wants it to. The triangles located at each data point that he had, and then they're being connected by a red line. with the line width that he has set up. So thank you very much for sharing your answers with me. And at this point, we have a line chart of speed on y-axis and time on x-axis. Can you go ahead and tell me your estimate of the speed at time t equals 5 seconds? So we are basically I'm going to add a line of code here so that we have a better view of our code. Let's go with the same size and see what happens. Okay, this fits better. So I used the plt.figure function that you have already seen Dr. Cleveland using it. And with this fixed size, we can set up the attributes of our plot box in inches. So 10 is the width and 5 is the height. And actually, if you want it in different aspect ratio, you can make it into a square and it will look like this. Or you can make it a little wider and it will look like this. But 10 to 5 looked good, so I'm going to keep that. So I want a volunteer to unmute and tell me their estimate on speed in t equals 5.
25.
25. How are you getting that?
I look at time 5 and then I go directly up.
Exactly. So if this is our t equals to 5, we can go straight ahead up, see and find the intersection, and then kind of go with a horizontal line up to here. So since I was using the mouse, that is not a pretty accurate estimate, but we have an answer for 25. Do we have any other answers? Are you putting things in the chat box? No? So yeah, we kind of would estimate somewhere around 25, 26, 27, 24 in that range. And that is one of the uses of a line plot. Another thing that you can understand about this plot is that as time is passing, our speed is increasing. So similar to what Dr. Cleveland discussed with you, we know that we have acceleration. Because if we didn't have acceleration, our speed would not change over time, and we would pretty much have a horizontal line. And since this is not a straight line, we also know that our speed is not changing linearly. It is changing non-linearly. We don't really know how it is changing, and that will be the topic of some other lectures that we will have in the future. So let us move to exercise 2. Do I have it here? One moment. So for some reason I cannot see the box for my exercise 2, but I hope that you can see it. Exercise 2 asks you to use the same series from exercise 1 and plot the speed. Thank you very much. Plot the speed versus time, the speed on y-axis, time on x-axis, using a scatter plot. From examination of the plot, estimate the speed at time equals 2. So in this one, we want to use the same data that we had, and we want to create scatter plots. This one can be a little newer, but I'm still going to give you a shot at it. So go ahead and tell me what you think we should have in the answer. So we have Ben coming in with his solution. Let's see. So he is defining the attributes 10 to 5. Then he's going with plot.scatter, time, speed, is going with a different color. Actually, that's something that I like. And a different marker. He's going with circles. The X label, the Y label, and the plot. So let's see what he has. Very good. So this is a scatter plot. And who can tell me what is the biggest visual difference that you can see between this one and the previous one?
No line connection.
No line.
Exactly. So the scatter plot is basically a bunch of points. And the bigger your lists are, the more points you will have. But the fundamental difference is that in the line plot, we are connecting those dots. Depending on the nature of the data set that you're dealing with, connecting them may communicate a completely wrong idea. Because actually, if you come and look at this, between each 2 points of this line plot, we are drawing a straight line. But we don't really know if the change, let's say, between time 0 and time 1 was linear. We only have measurements on 2 steps. So this could be any kind of line, linear or nonlinear. So depending on what you're working on, what kind of data that you're dealing with, you may not want to go with a line plot or with a scatter plot. Keep in mind the differences. So, how about the estimate? You are asked to estimate the speed at t equals 2.
Do we just print it out? I mean, it looks like it would be around 8.
Yeah, that looks like a fair estimate. Because actually a little past 0.2, you have a value less than 10. And at 1, you had a value around 4 or 5. So you would go with an estimate like that. Very good. So, in exercise 3, we are asking you to, again, using the same series from exercise 1, plot the speed versus time, speed on y-axis, time on x-axis, using the line plot, and then plot a second line based on the linear model y equals mx plus b, in which we want the value of b to be equal to 0 and m be equal to 7.6. So I am going to give you 2 minutes to work on this, and I want you to remember how we plotted functions before in the same lab. That is exactly the same. So you have a linear function here, y is equal to m multiplied by x plus b, and you have the value for the intercept and for the slope. So go ahead and give it a try. Let us see what you will have. Mark, what error are you getting? Well, that is a completely true statement, because you are plotting x and y as your lists, and they should have the same size. That simply means that if you have 4 points in time, you need 4 points in speed. There's probably something wrong with the way that you're defining your lists. Andrew, can't multiply by float. What are you trying to multiply by float? I would say that you probably need to change your approach. Jacob is coming up with a solution. Let's see. So he wants to plot time and speed. So basically this is what he had before. And then he wants to go in and do a line space function from NumPy from 0 to 7 with 1,000 points. And he's going to plot that as 7.6 multiplied by x in red. So let's see what he will get. So he will get something like this. And I wouldn't say that this is wrong. The only thing that I would say is that this definition of the plot that you gave is completely specific to this question and then these two. So in a lab notebook, so far what I've been doing is that if you had done something like this and your results were correct and you were not breaking any rules specified by the question, I would give you the point. But there is a cleaner version of doing this, which I'm going to show you. But thank you very much for sharing your answer. So let us define a function, and we can call it Y model. You can call it whatever you want. You just need to be consistent, similar to any other user-built function that you work with. In terms of inputs, we have the X model. We have the slope, and we have the intercept column. For that, I want the value of my y to be equal to X model multiplied by my slope plus the value of my intercept. And then I wanted to return my y value. So I defined my function based on this equation that I had. Then I am going to create an empty list for the output of my function. So far we have two lists, time and speed. That will give us the line plot that we have already seen, and that is good. To create the second line, I need another set of value for my y's that is calculated based on the equation. So I will go ahead and say y list, just an empty list. I can actually add comments here. Let's create an empty list for y. And then here the comment would be define the y model function based on the linear model given by the question. Okay. Then the initial value for slope is already given to us. So what is the value for my slope?
It's 7.6.
Thank you very much. And the value for my intercept?
0.
Thank you. Then I will go and use a for loop very similar to what we did previously in the lab. So the counter I'm going to go with is I. So for I in range of 0 until the length of my time list. So in my time list, how many values do I have? 1, 2, 3, 4, 5, 6, 7. So this will basically give me 7 numbers to count, 7 steps to count. Column. And then I want the values I calculate at every step to be appended to my list. So, y model, I'm calling my function on the element in my time list. So my y model needs how many inputs? Come on.
Length of time.
It needs 3 inputs. The x model, the slope and intercept. I already know the values for slope and intercept, and I want the value for my x to change at every step. So the ith element of my time list, and then the value I have for slope, and the value I have for intercept. So that will be my for loop, and I will explain that again in a moment. Once I have that, I have the list for y that I want. Now I can go ahead and start doing the plotting. Nope, sorry. So, yeah, that was a good catch. I called it ylist. So, we'll go with the same function that we used to define our attributes, which is plt.figure fixed size equal to 10, 5. That's it. And then I want to do a plot of my time and speed with, give me a color.
Purple.
Good call. Give me a marker.
O.
And give me, actually no, don't give me a line width. I'm going with line width 0. And then for my other plot, I want my time and
Y model?
Y list. So the list that I initially created here and I filled using my for loop is going to be my input for this step. And then give me another color.
Red.
Red. Then another marker.
U.
Did you say U?
P.
P. Okay. And then for line width, I'm going with 1. And let's go with plt.show. See what will happen. So, for this one, you see that these purple points are basically the values that we had, the time and speed values that we had. And this red line is the linear model the question gave us by y equals mx plus b. I want someone to volunteer and tell me what is wrong with this plot.
We don't have a line for the purple plot.
Do we have to?
We don't have a name for the y and x-axis.
Mm-hmm. That was a good catch. So I can actually go here, copy this, bring it down here, paste it, and then run it. And you will have the titles and the labels. So we don't always have to have lines connecting our points. In this example, as you can see, that kind of helps us to differentiate between our actual observations and what a model will estimate. So this linear model is estimating values at every time step that we had originally a measurement. Would you say that this line is a good fit for our data?
No.
Why?
Because if you were to estimate like 3 from the red line and 3 from the one with the purple line, you'll get like 2 very different answers. You'll get like 20 and then 10.
Very good. So first of all, as we discussed earlier, based on the linear plot that we had up here, we knew that this is changing nonlinearly. So we kind of had an initial guess that a linear function will not give us the best fit. However, if you look at the values at both ends, or sometimes we call that the extreme ends, 0 and 6, you will see that the line and the observed values are pretty close. But for middle range values, we are getting very terrible estimates. So if this was for a planning purpose, we would be either spending too much time and over-designing, or we would be under-designing and waiting for a disaster to happen. Do you have any questions about exercise 3? This is a very, very important exercise. You want me to send exercise 3. Here you go. Okay, so exercise 4 asks you to use a trial and error process to improve the fit of the model by adjusting values of M and B. I'm going to give you 2 minutes, and I want you to give me your best values for M and B that you think provides the better fit. And I want all of you to participate, so please don't feel shy. Brandon, I have some issues with the word smaller, because that is kind of relative. What do you mean by smaller?
So like instead of I believe 7.6, we decreased it to 7.
Okay. So I think you already have some answers. Let me copy the script I had for exercise 3. I'm pasting that for exercise 4. And I think Dule was the first one who gave me a guess. So what do you want for a slope? Dule?
7.
7 or 8.7?
8.
What number do you want for a slope?
8.
8. And for intercept?
-8.
-8. Okay. So let's run it. It will look something like this. And I can see why you feel that this is a better fit. This is a better fit because you may get a little further than what you were in the both ends, but you're getting closer in the middle values, and since you have 5 values in the middle, you are getting closer. So, who else did we have? Brandon, you want to give me your numbers?
Oh, my numbers were just 7 and 0.
7 and 0. So I would say this is slightly better than what I originally had, but Dulay's guess was better, was closer. Who else do we have? Travis, go ahead and give me your numbers. Okay. So I have 5 and 2 by Mark. Again, it is improving. So Travis says 5.5 and 0. Yeah, so I really appreciate all of you sharing your answers. So we realized that by changing the value of the slope and intercept of our linear model, it is possible to get a better fit. But the more important concept that we wanted you to learn is that you can have a function. It can either be a known function or something that you are getting from observations and experimental data. And then you can go ahead and add lines to that plot and visually assess whether it is giving you a good fit, a good capture of what is happening in your real data or not. So, do we have any questions about exercise 4?
So there isn't going to be like any defined answer. It's just as close as we can get.
Yes, actually, in every trial and error process, that is part of it, and that's why we usually do our best to avoid that. But sometimes it's inevitable. As you keep trying and changing those values, there's always a chance that you are getting closer or you're getting further away.
There, gotcha.
So can have some real fun if you modify function to, okay. Let's give this one a go. I'm creating a new cell to not confuse you. So our function is going to get X model slope of X, or I'm going to call it X underline a slope, then X2 underline a slope.
Got it. Cool.
And we have the intercept. Okay. Then we want B18 is one coefficient, right?
Yeah.
So we are going with X model multiplied by X underline a slope plus X model to the multiplied by X model, to make it a little more descriptive, multiplied by the X2 underline a slope, and then plus intercept, and it will return Y. So for X underline a slope, let us go with 2. For X2 underline a slope, let us go with 1. And for intercept, we will start at 0. Then for Y model, we want our Other variables do not change.
Cool.
Let's hope that this will do what we want.
Did you mean to do X model times, or like raised to the X model?
Yes. We're trying to introduce a quadratic model.
No, I think I had to multiply it, right?
Yeah.
Not take it to the power. That will probably be a closer yes.
There we go.
So now if you compare what was happening with your purple points or observed values and your fit or your model, you will see that this is giving you a way better fit. And you can actually go ahead and play with those numbers and see how it will change. So I am going to change this to half and see what will happen.
More curvature. Make that bigger, yeah. Sweet.
You see, this is a way better fit than a linear model because of the nature of your observations, what you had measured in real life. And this is one very useful way of using the Matplotlib library to do visual assessments and to get more information from a list of number, from actually two lists of number that you have. Do we have any questions about exercise 4?
Yeah, could you copy and paste that too?
Yeah, sure.
Thanks, dude.
This is not part of your lab exercise, so...
Yeah, I'm just going to add it like in a separate line.
To the other 80 people listening, you don't have to do the quadratic fit. Don't even try unless you really want to.
The first time that I was teaching a class in US, I wrote things on the board and then I looked at the students and said, okay, I'm going to leave it there for 2 minutes in case someone wants to make a note. And then I saw everyone just taking out their cell phones and taking photos. And this is just the new trend. You don't want to even take photos. Just copy and paste the script for us. Yeah, I will do that. I will do that. So, do we have any questions about exercise 4? The main body, not the cool part that we did at the end. Okay, I see nothing in the chat box. And let's move on. So, in exercise 5, we will be using the features of the Pandas library to create some plots. And I think you will be able to notice the differences and why you need one of them in some cases and the other one in other cases. So, for exercise 5, the question says, use Pandas to read a data frame from file census_18.csv. Then produce a line plot of the counts by age for the 2010 census. X-axis will be the series age, Y-axis will be the census values for 2010. This CSV file, the census_18, is something that you have already downloaded, I hope, and you have already uploaded on your CoCalc account. Again, I hope. So I'm going to give you 2 minutes, or maybe 1, to tell me your ideas about this script. The first part is basically reading a CSV file that you have already done on a previous session. And then you want to plot that. In case you do not remember how to do that from Dr. Cleveland's lecture, that is okay. We will go over that together. Okay, I have some volunteers. Max, Esteban, thank you. So let's see what you guys have. Oops. You are defining a function defining an object. You're calling the df. You're using the read underline CSV function from the Pandas library, and you want this file, and that should be the exact name of the file that you have in your working directory. And then you are using the head function. Why are you doing that? Esteban, come out and defend your code. No, nothing? That is actually a pretty good idea, because that will give you an initial idea of the data frame that you have just read into, and you can check whether that's the file that you want and what do you have in it. Because the head function is what is going to print out my data frame. The only thing that I want to add to that is that the head function do not print your entire data frame. It only prints the first few rows of your data frame. So if you have a data frame with 10 columns and 1,000 rows, it will give you, the head function will give you a data frame with 10 columns and only 5 rows. It will not show you the rest of the rows. What prints all of it? You can actually just go ahead and call df, and this will give you a full version of your data frame, similar to what Max had in his code. So, but usually, since in engineering you deal with large data frames, I prefer to go with head and not cause a chaos by calling the entire data frame. So, do we have someone who has printed or actually made the plot? In Pandas, if you have a data frame like what we have here, and you want to make a plot, what you use is the plot.line function. That is the name of the function that you want to use. The syntax for it is x equal the heading of the column that you want on your x-axis. So the question wants us to have age on the x-axis. So I'm going to call it age. Be careful. You want the exact same spelling of the column name. Otherwise, it will not understand what you're saying. Comma. Y is equal to what you want to be plotted on the y-axis. In this case, we want the values from 2010 to be plotted. So we go with y equals to 2010. Then we can set the label and say, okay, born in 2010. Yeah. And then for color, we can go with whatever we want. So I want a color. Give me a color.
Purple.
Yellow.
I like yellow better. So, but it usually doesn't plot very well, so we can have a look at it. And this will hopefully make a plot. There you go. The reason that yellow doesn't print well is that the background is white. If we had a colored background or a gray background, that would have looked much better. So actually, while you're working on it, let me go ahead and This is using something that we have not taught you before, so I will go back to this. For now, let us go ahead and change the color to purple. And it will give you a plot having issues with the DF. What kind of issues?
For some reason, it just doesn't want to activate the command to make the graph or anything.
Have you, so when you run this, you get an error?
Here, let me just take a screenshot real quick.
Yeah, okay, sure. So I saw another color in the chat box that I liked, so let's go with orange. Yeah.
It doesn't want to import it. Give me a moment. I'll get the screenshot real quick.
Okay, I'm waiting for it in the chat box. So, and that is how you use the plot.line function to plot two columns of a data frame in Pandas. While we're waiting for that, we can actually go ahead and look at exercise 6. It is asking you to use your data frame from exercise 5, and this time plot both the 2010 and 2014 values by age. Plot the 2010 distribution in blue and the 2014 distribution in red. You're going to have 2 minutes to give me the scripts of this plot. So, Osvaldo, let's see what you have. Name DF is not defined. Yes, because you're only running this line. In the line before that, you are missing this. This is where we are reading our CSV file and calling that DF.
Yeah, I kind of just realized that. I'm kind of stupid sometimes.
No, don't worry about it. It happens to all of us. So while you are working on yours, I'm going to work on mine as well. I'm actually going to copy what I had for exercise 5. And the question wants us to do 2010 in blue. And then the 2014 in red. Do I have a volunteer? Esteban. What? What are you doing, Esteban? What is this that you have? Why are you naming your df.pline.line ax? Why? It could be like any other plots. Why did you decide to name this one ax? And then in the second line, you have something that says ax equal to ax. Why is that? Berlin, that is right. That is right. So let me plot this while Esteban is thinking about why we have to go with his syntax. If we run something like what I have here, do exactly what we did before. If I run it, it will give me two plots, one for 2010 and one for 2014. But, actually, I need to change my label, and this will be even better. So, 2014, 2010, one of them is in blue, one of them is red, but it is giving me two separate plots. It is not plotting them on top of each other. And that is not what I want. So, the thing Esteban has here, and he said because it did not work the first time, because in the last example in the presentation it showed both data sets in one graph. Yeah, so for pandas, Esteban, are you trying to say something? It has a very Darth Vader-y sound effect on your voice. No, it's okay. So in this syntax, what is happening is that we are storing, or we are assigning our first plotting command to an object called x. And then in the second line that we are asking for our second plot, we add this little piece to our parentheses. And that basically means that I want this second plot to be added to my previous object, which was x. And if you run this, it will give you the two lines on top of each other in one single plot. And that's what you want. So, in fact, that is the way that you need to go with if you are plotting using pandas. And if you want to have two lines or multiple lines added to the same plot. Do we have any questions about exercise 6? Questions?
Can you just stay on the code for a little longer so I can see it?
Yeah, sure. That is actually your own code. How did you... Okay, look at this. This is where the trick happens. I am assigning my first plotting command to an object, and I'm calling that object x. You can call that whatever you want. And then, when I'm calling my second plot, or my second line, or my second curve, I'm adding this little piece of command to it, which basically means that I want this plot to be added to my other object, ax. And that's how it puts them on top of each other. If you just simply go with two plotting commands similar to what we did before, it will give you two separate plots. By using this syntax, it will give you one plot with two lines in it. Dane, actually, if we move on to the next example, this one is telling you how you can do exercise 5 and 6 using Matplotlib. So what you have already seen was using the Pandas library to get those plots. You can use the Matplotlib as well and get a similar plot. How? Here is how it works. So with Matplotlib, you always need lists. So how do we get those lists? We already had a data frame, which we have defined based on a CSV file. And we had called it df. So first, we go and we define our three lists. The list for age, the list for people born in 2010, and the list for population born in 2014. This is what is happening in the three lines here. Then I'm using the plot function. My first list, the one on the x-axis, is going to be age. The second list, the one on the y-axis, is going to be born 2010. And then I'm going with color blue and this label. And for the second one, very similar structure. Instead, I'm going with born 2014 and a different label. And then I want a legend to be shown on my plot, and then I want to run it. So it's just another way of doing the same thing. So I hope this answers Dane's question. Delay. So is there a reason it only works with X? Because I tried different variables instead of X, and I only got the first one and an empty second one with a bunch of errors. Let me give this a try. So if I name this Farhang, and I name this Farhang, it will still plot it for me. I'm assuming that you changed this one as well. Do not change the first X. What is happening in the first line is that you're basically assigning that to an object. As you already know, you can name your objects however you want. But in the second line, you need to put X equal to, that is always the same. That is like a built-in function. And then the name of your object here. I hope that was a good enough answer. Cody, did you fix that? Cool. So, do we have any questions about this example of how to do all that using Matplotlib? Why does that one not need X? X is basically the way for the Pandas library to do multiple plots in a single plot. With Matplotlib, you don't need that. That is something specific to Pandas. This is the way we do it in Matplotlib. So, as I've already told you, in many cases, you are able to do the same thing using different tools. So if you want to make a hole in a wall, you can either use an electric drill from Ryobi, or you can use an electric drill from Black & Decker. What will happen is that you will have a hole in the wall. Now, someone may prefer Ryobi because of its specific features. The other one may prefer Black & Decker because of that feature. It really is what you want as the user, and whichever one gives you the features that you want. Or a sledgehammer. Yes, that would be primitive Python. So, do we have any questions? Okay, so let us talk about bar charts a little before we run out of time. For exercise 7, we want you to create a data set like this. Can you tell me what kind of object is data? You've already answered Dr. Cleveland on this. Thank you very much. So this is a dictionary. How many keys do you see in this dictionary?
4.
4. How many data you see in this dictionary?
4.
Duh, yes. So we want you to create this data object and then produce a bar chart of number of students in each language, where language is the classification and a student count is the variable. Running out of time, I will tackle this myself. You can actually go ahead and follow me. So let us first create this. Can I copy this? Yay! So cool. Then I'm going to say language equals to my data. Actually, I want it as a list. So list of the data object and the keys. Because C, C++, Java, and Python are the keys in my dictionary. And basically, I'm creating a list. Oh, cool. So I just got notified that this is identical to something that you have already seen. So I'm not going to be too specific about it. So first I'm creating a list with my keys. Then I'm creating a list with my values. And then I can get to plotting. First, I want to go with a figure, which will be plt.figure fix size. And let us stick with 10 and 5. Then I want a bar chart. So I'm using the plt.bar function. This is the important difference that you need to notice. And for that, I have to feed different values. So I'm going with languages as the first input and the SD count as my second input, and then color, give me a color, fast, fast, fast.
Red.
Red. Okay. Then I can actually set the width of the bars, and we can go with 0.5 if you want. And this needs labels similar to what we had before. X label will be, come on, help me, languages, PLT, Y label, be student count, then PLT, the title, can be student enrolled in different language courses. And of course, we want it to show up. So let's hope that I haven't, oops, name language is not defined. Language.
Yeah,
yes.
you go.
So that will give me a bar chart. And you can go ahead, play with all these, the color, maybe the width, and eventually it will give you what you want. The biggest difference between this kind of plot and the previous ones is that we usually go with plot lines when there is some aspects to the continuity of data. So there is a connection between multiple points. With this one, it is discrete. They are not connected. So if I want, I can bring the bar for Java and put it right at the beginning, and nothing meaningful will change. But when you are dealing with time needs to start at, for example, 0 and go until 10. You cannot have the 5th second before the 7th second. That would not make sense. So the type of data, the nature of the data that you're dealing with, kind of tells you what type of plots you need to use. And then for exercise 8, you are asked to create a similar plot as a horizontal one. Since you have already seen it, I'm just going to paste the script here, and that's going to give you a rotation of the same plot. For some purposes, this one will work better than the other one, and sometimes the other way around. So we are at 10:48. Before I let you guys go, I have 3 things.
How did you switch it to horizontal?
The command actually changes to bar H instead of just bar.
Oh.
And then instead of width, you go with height. That is the only difference. So I have 3 files that I want to put in the chat box, and I believe you will find them useful. Oh, I sent them privately to Dr. Cleveland. One more time. So these are all from Data Camp, and if you look at them, they will be cheat sheets like this. I have given you the one for NumPy, the one for Pandas, and the one for Matplotlib. And this will kind of give you a general overview of different useful functions in each of these libraries. And I thought that you may find it useful. for all the different packages, especially the more common ones, you will find similar things over the net. So do not forget your best friend Google and how powerful it can be. So if you have questions for me and if you want to go over stuff, email me right now. And after this session, I will send you a Zoom link so that we can go over those issues. Dr. Cleveland, I am going to...
Real quick, how did you make it horizontal? I know it was var h or something like that.
Yes, here, instead of plt.bar, you go with plt.bar_h, and then instead of width, you go with height.
Okay, gotcha.
Or you could look at the Lesson 9 workbook.
So, Dr. Cleveland, shall I stop sharing and make you host again?
Yes, I'm going to terminate the call pretty quickly. Thank you all for your attention. I hope you have a great day. On Thursday be a quick review of everything for the exam, and then the exam begins. It's all programmed, subject to server errors. And do spend some time on this lab before the exam. You don't necessarily have to get it completed, because some things will appear again. You're already prepared for them, but they also were re-examined in this lab. With that, I will let you go. Thank you very much.
One last thing, because the question is there. No, we will not do another review session, but the link for the video of the one that we did on Sunday is available to you via Blackboard.
All right, goodbye.